Hello everyone, welcome to Maths IAC. Here's a question about a motor, and this is a proof question. Please pause the video and give it a try. When you're ready for the answer, press play. Motors often include a rotating shaft that performs mechanical work W. So this is the rotating shaft. A motor is used to lift a weight in time t. Now let's imagine this load was here, and in time t, this was lifted by a certain amount. Let's call this distance t. The shaft of the motor has a radius r here and applies a force F to lift the force, that is the tension of the string. The power output of the motor can be expressed using the relationship power equals the moment of the force here, which is F times R, multiplied by angular speed omega. So start with the basic equation for power and show how to derive this formula. Right now, what we need to understand for a question like this is let's just get a zoomed out image of the shaft. Now, this is the shaft, right? You know what you see here. This one is this one here, just to so that you have more space. Now, when the shaft turns this way, the string gets wound around it. Now, let's say when the string gets shorter by amount d, the angle here, let's take the angle to be theta. Now, this distance here will be d. Now, let's say when the distance of this, the length of the string wound is 10 centimeters, that means the load will go up by 10 centimeters. So if that is d, this is d. Now, the formula that connects the radius, theta, and this is S is equal to r theta. S is the arc length. So d is equal to r theta. Now let's start with the power formula. P is equal to W over T, work done over time. Now work done is force multiplied by distance over time. Now I know d is r theta. So I can substitute r theta instead of d. So I get this is equal to F times r theta over t. But what is theta over t? Theta over t is omega, angular speed. So power is equal to Fr times omega. So Fr is the moment, angular speed, omega is here.